Alright, so part 3 says let's approximate the area of the region bounded by the graph of, or the x-axis and the curve of f of x equals negative x squared plus 25 on the interval negative 1 to 5 using M3. So what does M3 stand for? It says I want 3 rectangles and I'm going to use the midpoint of each one of those rectangles. So this one gets a little more complicated when you get into some smaller values here, which you will see in the homework and you will see in the quiz and in the textbook. You will see some bad values here, but remember, we're just going to be using the table feature on our calculator, so hopefully it works out for you. Okay, so what are we doing again? It's the curve. Underneath the curve, interval is still negative 1 to 5. Same curve. We're using the midpoint, 3 rectangles. Now what's nice about this picture, if you look at this picture, it looks like I overestimate a little, but I also underestimate a little, so it seems to me like this one is going to be even more accurate than using the right endpoint or the left endpoint. So let's get our stuff together here. How many triangles do I want? How many rectangles? I want 3 rectangles here. Okay. The next question was, which endpoint am I going to be using? The endpoint that I want to use is not the endpoint, it's the midpoint. Okay, we'll look at that in just a second. Next thing I want to do is figure out what's the width of every single one of my rectangles. Again, it's the right endpoint, which is 5, minus the left endpoint, which is negative 1, divided by the number of rectangles I want, which is 3. 5 minus negative 1 is 6, divided by 3 would be 2. So that's my width of every single rectangle here. That gives me a good starting point. I'm going to start by drawing off that interval. I'm going to write negative 1 to 5. I'm going to break it into as many rectangles as I have. Well, it looks like I have 3 rectangles, so I'm going to put 2 slash marks, trying to space them semi-equally. Again, what do? Add the width of every single rectangle from the left. So start off with negative 1. I'm going to add 2. That would give me a label of 1. Add 2. That would give me a label of 3. Add 2. That would give me a label of 5. That's great. So now the question becomes, where do I use to determine the height of each one of these rectangles? I know the width of every rectangle is 2. What do I use to determine the height? And this is the one that we have to do a little more math. We actually have to find the middle of each one of those points because it wants us to use the midpoint. So what's halfway between negative 1 and 1? The answer is 0 in that case. How can you always get this? If it's bad numbers, what could you always do? You do the left endpoint plus the right endpoint divided by 2. So you're finding the average of the two numbers. So you would have done negative 1 plus 1 divided by 2. Likewise, you could do 1 plus 3 divided by 2, or just look at it. The midpoint here is the number 2, and the midpoint in between 3 and 5 is the number 4. So what numbers am I plugging in to get my heights? I'm plugging in 0, 2, and 4. If you notice, here's 0. That is the height of my first rectangle. Here's 2. That's the height of my rectangle. Here's 4. That's the height of my third rectangle. So you can visually see it right there. Again, I don't want you to rely on the picture, though, because the picture will not be given to you during the test. It's just to help you see what's going on. So what do? Well, we have to take the x values that we're going to be plugging in. And the x values that we wanted to plug in were 0, 2, and 4. We need to think about the height, and we need to think about the width of each one of these. Well, we know the width of every single one of these is 2. That's my delta x. Okay, that's delta x. That's my width. And then to determine the height, again, I'm just going to plug it into the function being negative x squared plus 25. Again, I'm probably going to use my table feature on this. You've already plugged in a bunch of these numbers, so you might already have the answers from the previous problems. But please go ahead and use that table feature. Type in negative x squared plus 25. Hit enter. Start doesn't matter. Step doesn't matter. Just make sure you selected ask. Hit OK. And then type in the numbers. So when I plug in a 0, I got a 25. When I plug in a 2, I got a 21. And when I plug in a 4, I got a 9. So hopefully you have those as the height of each rectangle. Again, we take the height times the width. If you take the height times the width, let's see what we get for the area of the first rectangle. I'm going to get an area of 50 units squared. 21 times 2 would give me 42 units squared. 9 times 2 would give me 18 units squared. So that's the area of each one of those rectangles if you visually want to see it. The first one has an area of 50, second one was 42, and the third one was 18. So what do? I add those three areas together. That gives me an estimation of, please double check my math, I'm getting 110, what would be units squared. So again, this one seems to me like it would be a closer estimation to the actual area beneath the curve using the midpoint over the last two problems that we did, which was the left endpoint and the right endpoint. So I just want you to understand what we're doing. I want you to understand my notation. We're estimating the area beneath the curve. When we did the left endpoint, we got 128, which seemed as an overestimation. When we did the left endpoint, when we did the left endpoint, it was 128, overestimation. When we did the right endpoint, it was 95, an underestimation. And notice now we're pretty close in the middle, which is about 110, which is our midpoint. Then we think that's a better estimation. So just take a step back. Let's think about the previous section. How would we actually find the area beneath the curve? Well, to find the real area beneath the curve, we would do the definite integral from -1 to 5 of the function, which was -x squared plus 25. Take that with respect to x, and then we could evaluate this definite integral and find the exact area beneath the curve. So again, the purpose of this section is to say, why does this area match, or how does this area match? Again, we're going to draw it together with the definition of the Riemann sum of the integral in just a little bit, but we are taking a step back and saying if we want to estimate the area beneath the curve, we could use rectangles. If we want to find the exact area beneath the curve, we could use the definite integral, and very shortly we will be learning the connection between the two. Okay, so what I want to do now is start going into some more difficult examples. These are the examples that you're going to start seeing in the textbooks. They're not any more difficult. The process is exactly the same. It's just you're going to get worse numbers on these ones. Where I took a nice interval and I broke it up at nice endpoints. Here you're going to have decimals, and that's okay. Don't worry about it. The process is exactly the same. So it says, use 4 rectangles to approximate the area of the region bounded by the graph of f of x equals x squared plus 1 on the x-axis, x equals 0 and x equals 2. Use the midpoint of each interval to determine the height of the rectangle. So that is the textbook version of that problem. For me, what the heck did I just say? I'm going to summarize it with my notation. What you're doing is you're using the midpoint in 4 rectangles. So again, my notation is M4. That means the midpoint in 4 rectangles. You have your function, you have your interval, and that's all you need to get going on this problem. So let's think about it. How many rectangles do I want? I want 4 rectangles. Okay, let's think about what point are we going to use? You're going to be using the midpoint instead of the right or the left. And let's think about the width of every single one of these. Well, it's always the right endpoint, which is 2, minus the left endpoint, which is 0, divided by the number of rectangles, which is 4. I'm going to go ahead and use the decimal version of this. You could use the fraction version. It doesn't matter. I just like adding decimals, a lot easier than I like adding fractions. So I'm going to say the width of every single one of my rectangles is 0.5. So let's draw that number line to visualize what's going on. We start at 0, we go to 2, we need 4 rectangles, so I'm going to have to do 3 cuts, 1, 2, 3. That makes my 4 rectangles. I need to think about what's the endpoint of each one of these rectangles. Well, it has a width of 0.5, so I'm just going to add 0.5 every single time, starting from the left. So 0, 0.5, 1, 1.5, and then you'd have a 2. Okay. Now we need to think about which one of those points are we using. Well, here's the cruddy part, is we actually need to use the midpoint of every single one of those rectangles. So I need to find out what is the value of the midpoint for each one of these rectangles. So again, all you do is the left endpoint plus the right endpoint, divide it by 2. So the midpoint of the first one would be 0.25. The next one would be 0.75. The next one would be 1.25. And the last one would be 1.75. So these are the values that we're going to be using for the height of all of our rectangles. And again, we know the width of every single rectangle is 0.5. So again, let's look at x. The numbers we're plugging in is 0.25, 0.75, 1.25, and 1.75. Those are the x values, or the endpoints of all the rectangles. Those are going to determine the heights of the rectangles. How do we get the height? We plug it into the actual function. That's going to give us our function, so that's our height. And then we also need our width. Remember, your width is always delta x, which in this case is 0.5. So I'll put that in every single time. We're going to multiply those numbers together. Once we multiply those numbers together, it's going to give us our area of each of the rectangles. We're going to add those together and get the total area. So I'm going to need to put in I'm going to use the table feature in my calculator. Once I go under the table, I clear out the function. I type in x squared plus 1, hit enter. I go down, I just hit enter, enter, make sure it's on ask, and hit OK. I type in the number 0.25. It's giving me a fraction, which is fine. I just convert it over. Use that double arrow right above the enter button to see what the decimal value of it is if you want. If you want to leave it in fractions, that's fine too. I'm just sticking with decimals here. So I got 1.0625 when I plugged in 0.25. See what it is when I plug in 0.75. I'm getting 1.5625. And the next one I'm getting 2.5625. And on the third one I got 4.0625. I multiply each one of those times 1/2, and then I add them together. I'm going to go ahead and spare showing you the multiplication times 1/2, and then add them all together, see what you go ahead and get. Please double check my math. I'm getting 4.625. So again, I apologize for the bad numbers. That's what it is in this textbook, but that's how it's going to be on the test. That's how it's going to be on the homeworks and the quizzes. So just be comfortable with using that table feature in your calculator to get those decimals. Make sure you multiply the height times the width. Don't forget the width, and then add up the area of each one of those individual rectangles to give us the estimated area. So again, what's the estimated area on the interval 0 to 2 of x squared plus 1 if we use 4 rectangles and use the midpoint of each one of those rectangles to determine the height? The answer is 4.625. Again, it would be units squared, but we don't have units in this problem.